Hi all. Uh, Today we are starting our fourth module, that is the sequential circuits. In the third module we have discussed about the combinational circuits, and that I have already said that the combinational circuits will not have the memory, but the sequence circuits will have the memory. That is the main difference between the combinational and sequence circuits. So the sequence circuits are those whose output levels at any instant of time are dependent not only on the levels present at its inputs at that time and also on the past inputs. Okay, so in the case of sequence circuits, the output depends on the present input levels and also on the past input. But in the case of common circuits, the output depends only on the present inputs. That's the main difference between the sequential and combinational circuits. Some examples are counters, shift registers, etc. We will discuss it later. And the block diagram of a sequence circuits can be represented as like this. That is, the sequence circuits are a combination circuits having a memory element. Okay, a simple case. The sequence circuits are combination circuits having a memory element. Okay, and also the sequence circuits can be classified as the synchronous sequence circuits and asynchronous sequential circuits. Okay, that is based on the clock pulse. And for the case of synchronous sequence circuits, for the working of a synchronous sequential circuits, it need a clock pulse. Okay, that is only after giving the clock pulse the circuit will provide an output. Okay, but in the case of an asynchronous sequence circuits, it is not depending upon the clock pulse. Okay, so synchronous circuits are having a clock pulse. The clock pulse is nothing but just like a square pulse. Okay, just like a square pulse. So it will have the transition between 0 and 1 like that. Okay, and the sequence circuits need this type of pulse for generating its output. Okay, that are synchronous sequential circuits. Okay, because of the absence of the clock pulse, these asynchronous sequence circuits are faster than the synchronous sequential circuits. Okay, and the main memory element we are using in sequential circuits are the flip-flops. The flip-flops are very important element in the digital circuits, and it can be viewed as a bistable multivibrator. Okay, bistable multivibrator. You have already learned in your previous subjects what is a bistable multivibrator, because it is calling like that because the flip-flops will have two outputs. Okay, one is Q and another is Q bar. Okay, Q bar is entirely opposite of that Q. Okay, that is, if you are giving an input, the flip-flops will give two outputs, Q and Q bar, entirely opposite outputs. Okay, and the representation of a flip-flop is just like that. There will be number of inputs will be there. Normally the flip-flops will have two inputs and a clock pulse will be there, and two outputs will be there, Q and Q bar. Okay, and the flip-flop using the clock signal are called clocked flip-flop. Okay, the flip-flops using the clock signal are called clocked flip-flop. Most of the system outputs can change state only when the clock makes a transition. That is, transition means the clock pulse we have already see that it is a square wave. Okay, the transition means when the clock pulse changes from 0 to 1, okay, or 1 to 0. So based on that transition, the flip-flops can be classified as positive edge triggered flip-flop or negative edge triggered flip-flop. Okay, the positive edge triggered flip-flops are those in which the state transitions take place only at the positive going pulse, that is positive going edge of the clock pulse. Okay, positive going edge means that is when the signal changes from 0 to 1. That is, you can see here, this is the positive triggered flip-flops are denoted as like this. That is 0 to 1 transition period. Okay, the flip-flops will change its state only at this 0 to 1 transition period. Okay, so in negative edge triggered flip-flop, the state transitions takes place only at the negative going edge of the clock pulse, that is 1 to 0. So you can see here, that is when the pulse is changing from 1 to 0, that is high to low. Okay, so only at that time the flip-flops will change its state. So both the positive and negative edge triggered flip-flops are represented like this. Okay, this is an SR flip-flop. We will discuss it later. Just an example of an SR flip-flop. Normally 4 types of flip-flops will learn in this module, that is SR, JK, T and D. Okay, so this is an SR flip-flop. So the positive edge triggered flip-flop is represented as like this, that is you can see a clock pulse here. Okay, so clock pulse, for a positive edge triggered flip-flops we are giving an arrow. Okay, for representing a positive edge triggered flip-flop we are representing an arrow like structure. For a negative edge triggered flip-flop we are using a bubble here. Okay, before the arrow edge we are using a bubble here for representing a negative edge triggered flip-flop. So that's the main difference between a positive edge triggered and negative edge triggered flip-flop. So positive edge triggered flip-flop will change its state only at the positive going pulse. Okay, and also in the case of negative edge triggered flip-flop, the flip-flop will change its state only at the negative going edge. Okay, so that's the basics of our sequence circuits, and in next video lesson we will learn different types of flip-flops. Thank you.